All right, so get this. Have you heard about this new AI?
Mm.
It's called BlueLM-V-3B, and it's really making waves.
Yeah.
You know,
Yeah.
because it's bringing the power of these like massive AI models,
Right.
the ones that used to only exist in like giant data centers,
Yeah.
right to your phone.
Yeah, it's pretty amazing.
We're talking about understanding like text and images, the whole 9 yards.
It's a huge step, yeah. You know, we've been talking about the potential of on-device AI for a while now, but
Yeah.
BlueLM-V3B really pushes the boundaries, I think,
Okay.
of what's possible on a smartphone.
What's the big deal about AI being on my phone?
Right.
Like, it already feels like my phone is listening to me half the time anyway?
Well, this is different.
Go
Think
ahead.
about the privacy aspect.
Okay,
So
go
your
ahead.
data stays on your device. You don't have to send it to the cloud for processing.
Okay.
And the responsiveness is instant.
Okay.
Imagine real-time translation or using augmented reality apps without needing an internet connection.
Okay, I'm starting to see the appeal.
Yeah.
But how do they even fit something as complex as a multimodal large language model onto a phone?
Right.
Like, those things are massive.
Yeah, and that's where the ingenuity of this research really shines through.
Okay.
They designed BlueLM-V3B to be remarkably compact.
Okay.
Only 3 billion parameters.
Okay.
To put that in perspective, some of the leading models out there have hundreds of billions of parameters.
So fewer parameters, smaller, more efficient model.
Exactly.
But does that mean it's less capable?
Well, that's the fascinating part.
Okay.
Even with this compact size,
Yeah.
BlueLM-V3B manages to hold its own against and even outperform models several times larger.
Wow.
They achieve this through some clever techniques like model quantization,
Okay.
which is kind of like compressing a file without losing the essential data.
Oh, okay.
Yeah.
So it's like they found a way to pack like more punch into a smaller package?
Exactly. Yeah.
Very cool.
Yeah.
I'm still curious, though, about how all the pieces fit together.
Okay.
We've got images, we've got text.
Mhm.
How does BlueLM-V3B make sense of it all?
So essentially it has a vision encoder for processing images.
Okay.
And a separate language model for handling text.
Okay.
And the real magic happens in the projector,
Okay.
a component that bridges these two worlds.
Okay.
It translates the visual information from the image encoder into a format that the language model can understand.
So it's like having two specialists, one for visuals and one for language.
Yeah.
And the projector is like the interpreter that helps them communicate.
Precisely.
Okay.
That seamless integration is what allows BlueLM-V3B to do things like answer questions about images, generate captions, even solve math problems presented visually.
Okay, now that we have kind of a sense of the overall structure, let's talk about how they achieved such remarkable speed.
Okay.
The paper mentioned they hit 24.4 tokens processed per second on a mobile processor.
Yeah.
That's fast.
That speed is really crucial for that real-time interaction.
Yeah.
And it really shows the team's focus on algorithm and system co-design.
Okay.
They use techniques like mixed precision,
Okay.
which basically involves using different levels of numerical precision
Right.
for different parts of the model.
So I'm guessing that means they were able to, like, optimize the calculations to be more efficient
Exactly.
without sacrificing too much accuracy.
Exactly. It's like understanding that you don't need to measure every ingredient to the milligram when you're baking a cake.
Right. Right.
Some things need precise measurements.
Yeah.
Others can be a bit more relaxed.
Makes sense. What about parallel processing?
Uh-huh.
I bet that played a role in, like, boosting the speed as well.
Absolutely. By splitting up the tasks
Yeah.
and running them simultaneously on different cores of the processor,
Right.
they effectively created a mini team
Okay.
of processors all working together to analyze the data. They really thought of everything.
But before we move on, I want to circle back to something that caught my eye in the paper.
Okay.
This idea of relaxed aspect ratio matching.
Oh, yeah.
What is that all about?
You're picking up on the nuances.
Well, I try.
That's a really clever solution they came up with to handle those high-resolution images.
Okay.
Imagine you take a photo with your phone.
Yeah.
It's packed with pixels.
Right.
Now imagine trying to analyze every single pixel in that image.
Right. It would take forever.
It would take forever.
Yeah.
So instead,
Yeah.
they devised this relaxed aspect ratio matching,
Okay.
which is essentially a smarter way to resize the image for processing.
Gotcha.
It ensures that the AI gets enough information to understand the scene without getting bogged down in unnecessary detail.
So they found, like, the sweet spot between having enough detail
Yeah.
for the AI to do its job,
Exactly.
but like keeping things running smoothly.
Exactly. This dynamic approach to image resolution is another reason why BlueLM-V-3B is so efficient on mobile devices.
Okay, so we've covered the how of this amazing model, but I'm itching to get into the so what.
Right.
What does BlueLM-V3B's success mean for like the average smartphone user?
Yeah.
We'll dig into that in part 2.
Sounds good. Welcome back.
Last time we unpacked how BlueLM-V3B manages to be so compact and speedy.
Right.
But the big question is, how does all that translate into actual performance?
That's where the benchmark tests come in.
Okay.
They put BlueLM-V3B through its paces on a series of standardized tests.
Okay.
And the results are pretty compelling.
All right, give me the highlights. Did it live up to the hype?
It exceeded expectations, actually.
Right.
It went head-to-head with other leading AI models, including some that are much larger, and in many cases, it came out on top.
Hold on. You're telling me this little model, the one designed to fit on my phone, outperformed these massive supercomputer-powered models? How is that even possible?
Well, it speaks volumes about the power of smart design and optimization.
Okay.
Remember how we talked about relaxed aspect ratio matching for images?
Yeah.
Well, that clever technique played a big role in boosting efficiency without sacrificing accuracy.
So it's not just about brute force.
Yes.
It's about working smarter, not harder.
Precisely.
Okay.
For example, on a visual question answering benchmark called VQAV2, BlueLM-V3B achieved a score that puts it right up there with the top performers.
So what does that score actually mean in practical terms? Like, paint me a picture.
So imagine you're looking at a complex diagram or a chart full of data. You could just snap a picture with your phone, ask BlueLM-V3B a question about it, and it could give you an accurate and insightful answer.
Wow.
All in real time.
That's like having a personal data analyst in my pocket.
Right.
What other benchmarks did they test it on?
They ran it through a gauntlet of tasks, including document understanding, image captioning, even solving math problems from images.
Really?
And across the board, BlueLM-V3B demonstrated remarkable proficiency.
Okay, so I'm starting to get a sense of just how versatile this model is.
Yeah.
But I think it's important to, like, ground this conversation in reality.
Yeah.
What are some real-world scenarios where this kind of AI could make a tangible difference in people's lives?
Well, the potential applications are vast.
Okay.
Let's start with education.
Okay.
Imagine a student who's struggling with a concept in a textbook. They could take a picture of the page.
Okay.
And BlueLM-V3B could provide personalized explanations.
Wow.
Even generate practice problems tailored to their specific needs.
It's like having a tutor that knows exactly where you're getting stuck and can adapt to your learning style.
Exactly.
That's amazing.
Or think about healthcare.
Okay.
Someone in a remote area without easy access to doctors could take a picture of a rash or describe their symptoms to BlueLM-V3B, and it could provide preliminary guidance. Okay. Or even help connect them with the right medical resources.
That's powerful.
Right.
It could democratize access to information and expertise. Especially in areas where resources are limited.
Exactly.
Yeah.
And let's not forget about accessibility.
Yeah.
For people with visual impairments, BlueLM-V3B could provide real-time descriptions of their surroundings.
Oh, yeah.
Making navigation in daily life easier.
It's amazing to think about how this technology could bridge gaps and empower people.
Yeah.
In so many different ways.
It really is.
Yeah.
And we've only just scratched the surface.
Yeah.
As developers get their hands on this technology, I think we can expect a wave of innovative applications that we haven't even thought of yet.
It's like opening a door to a whole new world of possibilities.
Exactly.
But before we get too carried away with the excitement, I think it's important to acknowledge that there are potential downsides to consider as well.
Absolutely.
Like what?
Well, while BlueLM-V3B was designed with privacy in mind, keeping the data on the device, there are always concerns about security vulnerabilities.
Right.
Ensuring that this powerful AI technology doesn't fall into the wrong hands is going to be crucial.
And as with any AI system, there's the question of bias. If the data used to train the model is skewed or incomplete, it could lead to biased outcomes or inaccurate results.
Exactly. So it's crucial that the development of BlueLM-V-3B and similar technologies prioritizes fairness, transparency, and accountability.
It sounds like a lot of responsibility comes with this power.
Without a doubt.
Yeah.
But I believe that with careful consideration and ethical development, this technology has the potential to do far more good than harm.
Well, I'm definitely excited to see what the future holds for BlueLM-V-3B.
Me too.
But for now, let's shift gears and delve a little deeper into the technical details of how this remarkable model was built.
Let's do it. We'll unpack some of the key innovations that made it all possible.
So we've talked about what makes BlueLM-V-3B tick.
Right.
And explored some of the ways it could, change our world.
Yeah.
But before we wrap up, I'm curious about the nuts and bolts of its development.
Yeah.
What were some of the, key innovations that made this breakthrough possible?
Well, I think one of the biggest hurdles was figuring out how to train a multimodal model.
Okay.
One that understands both images and text on a data set that's both massive and diverse.
Because training an AI is like teaching a kid, right?
Exactly.
You need to show it tons of examples.
Yeah.
And those examples need to cover a wide range of situations.
Absolutely. And in the case of BlueLM-V-3B, they needed a data set that included not just images and text individually, but also examples where the two were paired together in meaningful ways.
So like a picture of a cat with the caption, "Fluffy cat napping in the sun."
That's the idea.
Okay.
They curated a massive data set from a variety of sources, including publicly available image caption pairs, web pages with, rich visual and textual content.
Okay.
And even data sets specifically designed for multimodal learning.
That sounds like a lot of data wrangling.
It is a lot of data.
Yeah.
But how did they make sure that the model learned the right things from all that information?
Right.
That's where the training process comes in.
Okay.
They used a technique called contrastive learning,
which
essentially involves presenting the model with pairs of examples, some that are similar and some that are different.
So showing it two pictures of cats and saying these are similar, and then showing it a picture of a cat and a picture of a dog and saying these are different.
You got it.
Okay.
By forcing the model to distinguish between similar and different examples, they encourage it to learn the underlying features and relationships that define those categories.
It's like a game of spot the difference for AI.
It is a very sophisticated game, but yes. And this contrastive learning approach is crucial for teaching the model to understand that complex interplay between images and text.
Fascinating. But I imagine training a model this sophisticated requires a lot of computing power.
It does.
How did they manage that?
So that's another area where they really pushed the boundaries.
Okay.
They developed a distributed training system that allowed them to leverage the power of multiple GPUs, graphics processing units, essentially creating a supercomputer out of many smaller units.
So like a team of ants working together to lift something much larger than themselves?
That's a great analogy.
Okay.
Yeah, this distributed training approach allowed them to train the model much faster than would have been possible on a single machine.
It's amazing to see how much effort and innovation went into every stage of BlueLM-V-3B's development.
I agree.
They really pulled out all the stops.
They did.
And the result is a model that's not just groundbreaking in terms of its capabilities, but also in terms of its efficiency and accessibility.
Yeah, it's a really big deal.
It's a true testament to the power of human ingenuity.
Yeah.
And the potential of AI to transform our lives.
Couldn't agree more.
Well, that about wraps it up for this deep dive into BlueLM-V-3B. A huge thank you to our listeners.
Yes, thank you.
For joining us today.
We hope you enjoyed it.
Be sure to check out the show notes for more information and let us know what applications of this tech excite you the most.
Yeah, we'd love to hear from you.
Until next time, keep exploring, keep questioning,
and
keep that spark of curiosity alive.